This video is about absolute value inequalities. All right, and we're going to focus on how do you solve, graph, and write absolute value inequalities. So our steps for solving are pretty simple. We're going to solve for the absolute value. Remember, that means that we're going to have two inequalities in this case. So we're going to solve for the absolute value by applying the definition of absolute value. That definition is what leads us to the two inequalities. But then there's one trigger thing that we have to really pay attention to. If we are involving a less than is going to indicate to us for absolute value that it will be an and inequality. A greater than means that we're going to have an or inequality. Okay? And then when we rewrite these, when we're doing this, especially with the or, we want to go same or same flip opposite. And you'll see this when we get to a couple examples. Once we have it all set up and established, okay, then what we're going to do is solve each inequality separately and graph it and write the answer in a simplified form. All right, so let's start off with this first one. We have an absolute value is less than 5. Okay? If the absolute value is less than, this symbol right here is telling me right away it's an and inequality. Now, I have to rewrite this by applying the definition of absolute value inequality. And here's how it works. Every time it's an and, you're going to write down what's in the absolute less than whatever was given. So notice we just rewrote what was given without the absolute values. But we know that the absolute values tell us there has to be another one. I'm going to put a less than before what was inside the absolute, and then put the opposite of 5 in front. The opposite of what we had on the right side in front. Okay? This is applying the definition of an absolute value inequality. It only can be written like this when it's an and. Now, once I have it established, I'm going to solve it. So I'm going to add 1. We got to get x by itself in the middle. So that would be -4 less than 2x less than 6. Divide everything by 2, so I would have -2 is less than x is less than 3. And this is now written in a simplified form as an and inequality. So again, notice, the less than just tells me it is an and. The symbol tells me what type it is. Okay? The last thing to do would be to graph this. So I'm going to draw a number line right here. I have a -2. I have a 3. Open circle on both. And shaded in between. That's it. All right, let's take a look at the second one here. Absolute of 3x minus 4. Okay, the absolute value is solved. Is less than or equal to. Less than or equal to means and 8. All right, so I'm going to rewrite this by applying the definition of an and absolute value inequality. And that would be -8 less than or equal to 3x minus 4 less than or equal to 8. The only ones that can be written like this again are ands. Now I solve inside out, so I'm going to add 4, -4 less than or equal to 3x less than or equal to 12. Divide everything by 3, -4/3 less than or equal to x less than or equal to 4. X is by itself in the middle. Therefore, this inequality is solved. Okay? So the next thing that I need to do is take this inequality and graph it. When I graph it, I know I'm at -4/3 here. I'm at +4 over here. I have a closed circle because it's a less than or equal to. Closed circle because it's a less than or equal to. And I know that this symbolizes shading in between. All right? Take a look at example number 3 here. All right? I have an absolute value is greater than 6. I always think of greater than. I say it in my head as greater than. That reminds me that that symbol indicates we're dealing with an or. Now, the or I have to separate into 2 distinct inequalities with an or in between them. It's not difficult to do, but you got to be able to follow a pattern. I outline that pattern right here where I have same or, same flip opposite. So here we go. Take the inequality and drop the absolute. 2x plus 4 greater than or equal to 6 or. So I rewrote it without the absolute values. Now I've got to think. I want to keep the part inside the absolute the same, 2x plus 4. I want to flip the inequality, less than or equal to, and take the opposite of 6, which would be negative 6. This is the setup for an or absolute value inequality. Yes, it has to be written like this, as 2 separate inequalities. It can never be written the way that we were writing the ands. It has to be written like this when it's an or. I'm going to solve each now. Subtract 4. 2x is greater than or equal to 2. Divide by 2. X is greater than or equal to 1. Or, subtract 4. 2x is less than or equal to negative 10. Divide by 2. X is less than or equal to negative 5. I'm going to graph this now. Let's see, I have a negative 5 and a positive 1. I have a closed circle on the negative 5 shaded to the left. I have a closed circle on 1 shaded to the right. And then I'm going to write my final answer as the first inequality, which says x's are less than or equal to negative 5, or the second one, x is greater than or equal to 1. So again, notice how I'm using the graph to write my final inequality. Solution. All right, let's try number 4 here. It says absolute of 5x plus 10 is greater than 15. All right, I got to, again, we didn't see any examples where we had to solve for the absolute value. It was already by itself. If there's any numbers outside the absolute value, I got to get them to the other side of the equation first. All right, this indicates to me that this is an or. I'm going to write it as such. 5x plus 10 greater than 15, or same flip opposite. So 5x plus 10, flip the inequality, opposite of 15. I solve each inequality independently. 5x is greater than 5 by subtracting 10. Divide by 5, x is greater than 1. I solve the right one by subtracting 10. 5x is less than 25. Divide by 5, x is less than negative 5. I take those inequalities, I graph them. I have a negative 5. I have a positive 1. At the negative 5, I have an open circle shaded to the left. At the 1, I have an open circle shaded to the right. I'm going to show that solution as my final answer, which would be x is less than negative 5, or x is greater than 1. And that would be my final simplified answer. All right? So what I included next was just kind of a simplification or a breakdown of how to do all absolute value. This is kind of the definitions, if you will, for all absolute value equations and inequalities. Now, the last thing I wanted to talk about here was something that is known in mathematics as tolerance. All right? What tolerance basically is saying, guys, is it gives me the ability to write an absolute value inequality in order to represent kind of like a span of values that are acceptable. Now, I chose this race car to kind of show you. What they say in a race car is they want the height of the car to be 52 inches, but they give a little bit of flexibility. They say it's still legal if it's 53 inches, okay, but it can't be any higher than that, or if it's 51 inches and it can't be any lower than that, okay? All right, so this idea of tolerance allows us to write an inequality. Now, I'm going to take you guys kind of on a little bit of a different way right here on how to do these. Here's what I know. I know that our smallest value here is at 51 and our largest value is at 53. I got that from the picture, okay? All right, and what I have to be able to do is I have to be able to do an inequality to represent this. Well, here's what I do know. I could rewrite this as 51 less than or equal to x less than or equal to 53. But can I take that now and kind of undo what we have been solving? And this is where the idea of tolerance comes into play. They say that tolerance is 1/2 the difference of the max and the min accepted values. All right? So I know right here that my tolerance would be 1/2 of 53 minus 51, which would be 1. All right? I take this information and I'm going to write the absolute value inequality now that I know would lead me to that solution that I started with. And this would be the absolute value of x minus 1 must be less than or equal to 52. Now, where did the 52 come from? That 52 was that desirable height, okay? And if you think about it, if you add 1 to 52, all right? If you add 1 to 52, you get 53, all right? And how do we get that 51? Maybe this isn't the way to do it. Maybe this is not, because, again, if you were trying to solve this out, I would have negative 52 less than or equal to x minus 1 less than or equal to 52. That's not going to work. So let's try to rewrite it a little bit differently then, okay? What about this? What if I say absolute of x minus 52 is less than or equal to 1? What if I put that tolerance on the right? Okay, well, let's try it. So let's see, we've got negative 1 less than or equal to x minus 52 less than or equal to 1. All right, if I add 52 over here, I get 51. If I add 52 over there to the right side, I get 53. And that was what we started with right here. Therefore, I know this would be my absolute value inequality. All right. Good luck. Let me know if you guys have any questions, and we'll go from there.